Today we're going to find the area enclosed by the ellipse. So let's first of all picture an ellipse. Imagine this circle right here is an ellipse. What we're going to do is we're going to find 1/4 of the area, multiply that times 4 since there's 4 pieces, and we're only going to deal with the positive section, quadrant 1. Now let's go to the formula of an ellipse. X squared over a squared plus y squared over b squared equal to 1. First step, solve for y. Let's move x squared over a squared to the right side. And now we're going to multiply that times b squared since we're dividing y squared. And the one before it. We're going to find a common factor since we're subtracting, which is going to be our a squared. Subtract that, distribute, gives you this a squared on the denominator. Distribute that under the radical. Since you're squaring something under a radical, you could take it out to the outside since it's just to the power of 1 at that point. Now, we're given on this form, if we have the square root of a squared minus x squared, we can sub that for x is equal to a sine theta. So since we have that here, we're going to go ahead and substitute that. Which brings us up here. X is equal to a sine of theta. We get our derivative. And now we're going to write it in terms of x squared. We're going to bring that down here. A squared minus a squared sine squared of theta. Square that. We're going to use trig identities to get us all the way to cosine squared. We get the absolute value of cosine. Since we're only dealing with the positive, we could go ahead and take off the absolute value. X is equal to a cosine of theta. Now we're going to plug that into the actual area of the ellipse. Since we're getting 1/4 of this ellipse, we start off with 1/4 of the area is equal to b over a, with the definite integral from 0 to a, square root of a squared minus x squared d of x. Now we could bring that 4 to the right side and multiply everything by 4. So our area is going to be 4 times b over a to the definite integral from 0 to a, square root of a squared minus x squared. Now we're just plug in, substitute our a squared minus x squared with what we have over here. Do our algebra, get it all the way down, simplify it, and then we're going to change the limit of integration since we're only dealing with theta between negative pi over 2 and pi over 2. So we change the limit of integration. First, we'll let x is equal to 0 and x is equal to a sine of theta. Let's solve it simultaneously. 0 is equal to a sine of theta. Let's bring this sign to the outside, this 0 to the right, letting us divide over a. So now we have sine of theta is equal to 0. Therefore, sine inverse of 0 is equal to theta, which gives theta is equal to 0. So that's going to be our a when we get our definite integral. Let's do it again. Now we'll let x is equal to a. Same idea. Now we're going to divide by a on both sides. This is going to give us a 1. So now we have 1 is equal to sine of theta since these a's cancel out. So sine of theta is equal to 1. The inverse sine of 1 is equal to theta, right? If we go to the graph of sine, go to pi over 2, it's equal to 1. So then our theta is equal to pi over 2. Now let's plug that in. We have our area is equal to 4 times AB of the definite integral from 0 to 2 cosine squared of theta and d theta. That's from what we did before. Now we're going to use the half angle identity. Instead of writing cosine squared of theta, we're going to write it as 1/2 times 1 plus cosine 2 of theta. We'll move that 1/2 to the outside of the integral and leave the numerator. Now we're going to rewrite everything in terms of u and integrate at the same time. So u is going to be 2 of theta. Derivative of that is going to be 2 d theta. We need to divide du to get our d theta. And that's what we get over here. Evaluate it from 0 to pi over 2. We'll use evaluation theorem. Subtract. And we're going to get 2ab times pi over 2 plus 0. Now, let's go to the final answer. So this is what we got. We could cancel out the 2's, leaving us with a is equal to ab times pi. The 0 goes away. Now, what if we let a is equal to b? Then we have a is equal to a times pi, which is just a squared times pi. What if we let our a, which is the point from 0 to a, which could be any point, let's let that be the radius of the ellipse. So we're going to substitute a squared for r being our radius, which gives us ultimately a is equal to pi r squared. And that's how you get the area enclosed by an ellipse.